And so, one last thing that I meant to grab the book as my prop. We actually have an author in our midst. So, mastering UPSs. Frank Aiello. Where's Frank? Over in the corner. Frank, thank you so much for coming out tonight. Frank has a book here. He was so gracious to bring some copies. He's going to sign them. Listen, I would bag it and tag it because it's going to be worth money because Frank he's legit, right? So, opportunity at the end to get some books in the back from Frank, but thank you so much, Frank. God bless. Good luck with this. All right. Without further ado, I'm going to call up our panel and let's kick off the conversation. Thank you all very much.
Oh, that's a great light. Yeah, it is. Are we gonna? Oh, Jesus Christ. Yeah, I'm just paying. Get out of the way. That's like that. Are we gonna? You want to tip it up a little bit? Like that?
I just got shoved it off. Is that good?
God. Okay. That works.
Well, it's been a year. It's been a year since we did this. It's deja vu. It's all the same guys. Welcome. So, what did we talk about last year? We talked about power and cooling. We're going to talk about power and cooling again. There's one thing that I missed, though, was the memo on the haircut.
You lost it. You lost it.
You got to hold the button in. So I'm very happy to put this together with these two gentlemen. They're quite the experts on power and cooling, and I think. Can you hear? Here.
Hold it down.
It's green.
IT. AB.
Power guys can't figure out power.
Yeah, that's fine.
Now we can't.
I broke it.
I don't think I'm going to need it.
No, it's on.
No.
Yep. Yeah. So we did this last year too, and we had a lot of fun doing it. We had an engineer here last year, but I think the two gentlemen here are quite the experts on power and cooling. So just want to say welcome to you guys and thanks for doing this, obviously, today. Just a little bit of background on me. I started the data center business in 1988. I looked that old, really? 1988. There were no data centers.
Hey, well, had CDs though, right?
Yeah,
Hey, well, had CDs.
you're up again.
I didn't do that.
Yeah, it's which is yellow. Just yellow. Anyway, so I'll never forget this, right? We started off with Prodigy and IBM, and we were building pop sites, and the pop sites were not what we thought they before the cell phones. And it was we built them. They were 100 kVA pop sites, 48 volts. That's how we all communicated then before you had phones. Well, look where we are today. You know, how many years ago was that? It wasn't all that long ago. And so I thought it was pretty interesting to read the Wall Street Journal and to watch NVIDIA and watch DeepSeek and these guys talk about 1,000-watt chips. We never had this before. Right? This is something fairly new. And I think the idea today is everybody wants to expand and everybody wants to go ahead and build a data center and a gigawatt worth of power. The question today is how do we find that gigawatt worth of power? And I laugh because I say data center is a giant hairdryer. You know why? Because you put the power in and you got to suck it back out again.
I wouldn't know anything about a giant hairdryer. But thank you. See, I understand the analogy.
So let's kick it off with a little bit of power stuff. Just to set the stage. How many gigawatts today do we put on our utilities? Does anybody know that we burn today? Total? Do we know?
No.
Yeah,
Because everybody's got a different.
it's all different, but it's roughly 485 gigawatts, somewhere around there, right? Data centers today, we're talking about gigawatts of data centers. Your average data center, like a hyperscaler, he wants to get a gigawatt of power today. They believe that data centers use 5% of the power on the grid today, and we believe it's going to be 5, 10, I read the other day, 15% growth. in that particular vertical. So the question is, how do we deal with the power profiles? What do we do to get power today? As you know, the utility's kind of out of power. To get a connection today with the utility, it could be 5 years. So how do we build these data centers is really the question. We need gigawatts worth of power. How do we get there? So I think that's a good topic to start off with today. So give us your rendition of where you think the power is coming from. That's a good place to start.
I mean, I'll even get into some of the other considerations around the numbers, right? It's, do you want me to introduce myself? I'd like to introduce you. So for those of you who don't know me, I'm Mark Gusakov. I'm the Chief Certification Officer for the International Data Center Authority. I am also a Nomad Futurist. Nomad Futurist is a nonprofit 501c3. We are demystifying the digital infrastructure community in space for emerging talent, trying to offset the workforce development issue that we're thrust upon here with 77% of our industry having a decade or more in, and 45% of those people having 2 decades or more in. We need to capture that knowledge resource for what's leaving, and then be also able to welcome in the people that are coming, because we have 300,000 jobs that we're going to need to keep up with everything that Rudy just said. So that's the nonprofit side of things, but from the other side, IDCA is the global certification body to recognize regulatory compliance across the digital infrastructure space, really looking at it from a holistic global digital economy position.
Thank you, Mark. So Neela called me a couple weeks ago and said, Jeff, do you want to come up on this panel? And I kind of thought, me? What do I bring to the table when there's guys like this? So you can tell, you know, an expert. Rudy's been doing it since 1988, but I'm happy to be here. I do consider myself a rookie in the data center world. I've been around this industry for only about 3 years. In that time, I was responsible for on-site power generation with a gas turbine company. We owned arguably the biggest fleet of gas turbines in the States, and so that's where my background lies. I've recently made a transition to a much larger company called Chart Industries. Chart is a global manufacturer and engineering firm, 12,000 employees, 1,500 engineers worldwide, 56 manufacturing facilities, and we do everything from heat rejection, on-site power in terms of ancillary gear for LNG, hydrogen, carbon capture, nuclear. If you ever watched a SpaceX launch, one of Musk's ventures, we built all those tanks in the background for SpaceX. So it's a very diverse company that I'm at now. And we've got many products that can be used in the data center world. So we're going to start with the power generation side, which is obviously my background, and then we'll get into a bit of cooling as well.
So I'll start with some of the numbers that you were talking about earlier, Rudy. The numbers are funny. It depends where you are, and it depends who you talk to, and it depends who you ask. I just came back from London, and when you talk about the global position, they have a much different view, right? When we're talking about what we're seeing in North America, I remember when the power consumption curve was data centers made up 3% of the total energy consumption category globally. And it was actually like 2.7, and it was verified. And then it was 3, and then it was 3.1, and now it's 3.3. And it's like, well, not a lot has changed yet for it to be that. But there is some doom and gloom, and there's some perspective around what we're going to have to do with AI, and I think there's some predictive number generation. I'm just going to be honest. So let's call that AI around the numbers. That I think there are some false predictions around actually how we're impacting, because as we know, agriculture actually makes up more of an impact in energy consumption globally. But I'll digress. The predictive models are saying that we're going to double our energy position in the global digital economy. We're going to double from where it is today by 2030, and could triple. Those are some really big numbers. Those are some big, broad sweeps. But we do know that we have doubled since 2017. So that's a pretty big impact. So let's look at 2017 till today, knowing how things have advanced and what we've seen different. Now, I'm probably going to pick on you a little bit because you've got more experience than I do. Like Jeff, I only have 3 years in the industry. But I came from industrial automation. So I'm starting to see a lot of crossover from people who are in industrial automation, process control, pharmaceutical, healthcare, even educational entities and research hospitals that are starting to come into the digital infrastructure community. So there's a lot of crossover, as we know, people who are manufacturing products, like you guys. You have an industrial component. You have an industrial automation manufacturing component that then crosses into digital infrastructure. So starting to see a massive emergence into that. So grabbing that technology and bringing it in here. As we start to look at what this power curve is going to look like and where we're going with it, I'm seeing some different avenues that are a bit shocking. Now, I love talking about the nuclear position. And I think that we've heard for too long that people said, oh yeah, we're going to have a nuclear deployment in SMRs in 3 to 5 years, 8 years ago. And we know where we are today. I sit on the advisory council with Idaho National Labs, Department of Energy, Department of Defense, and I am a liaison representative for Idaho National Labs, and I can tell you that there isn't going to be a deployment of an SMR nuclear reactor at earliest till 2029, and it's looking more like 2030. That will be the first one that we see. The second and third will probably be 2032, 2033 for an actual deployment. And we talk about, and I'll probably have you chat about this because you have a lot of knowledge on it, I personally believe that the gap here in North America, which is going to be very different than Europe, by the way, I think the gap that we have is we've got to start thinking about what we're going to do for on-prem natural gas. Use that as a bridge to get to the nuclear, not ditch the natural gas, but leave the natural gas on-prem for backup so that we're not dependent and relying on diesel, although we'll probably have to have some reliance on diesel, and then use that as the bridging gap tool, but it's geographical. And I'll give one shocking thing, and then I'm going to turn the mic over to Jeff to share some of his opinions on it, because he's got really good ones. I was just on a panel in London with Brian Smith from Idaho National Labs, commercial deployment director for them. And when I first got to London, there was a lot of pushback on nuclear. Nobody wanted it. I was like, Brian, we're going to get shit thrown at us. Like, this is bad. This is getting ugly. Billionaires were coming at me, telling me I was an idiot thinking we were going to deploy nuclear here. And I'm like, we're going to get in a lot of trouble talking about this, but let's do it anyway. There were a very select number of people who were against it. Then when we got in and we started talking about it, the people who were interested were the ones that wanted to listen. The people who were against it didn't want to be in the room anymore. So we were trying to educate and do what we could. I asked a question. This is my favorite part. I asked a question. I said, how many people out here, let's say there were 110 people in the audience, so how many people here believe in nuclear power being the next advent to get digital infrastructure to where it needs to go with the power demands that are in place? And the hands went up, and Brian and I looked at each other, and everybody in the crowd, minus 10 people, raised their hand in England. And we looked at each other like, holy crap, I can't believe that this is what's happening. We thought we were going to come here and get rotten food thrown at us. People are actually saying that this is the resource. And then Brian goes, wow, what do we ask next? And I'm like, I got a better one for you. How many people in the crowd believe that natural gas is a bridging tool to get us there? And the shocker came when only 10 people raised their hand. So out of 110 people in a crowd, who 90% of them thought nuclear was a viable resource, only about 10 of them felt that natural gas was an appropriate bridging entity. Anybody want to guess why?
They don't have it.
You know why they don't have any?
Because we're in Europe.
You know why?
Russia.
That's it. So Russia pulled the plug. So now you've got, but follow that path, right? So if you just stop and think, well, they don't have any, if you don't start asking the questions about why, they don't even know that it's a real resource. We take for granted in New York State, we got Marcellus Shale, we got Pennsylvania, like we kind of take for granted that this is a very reliable resource for us to be able to access. In England, they don't got none. But there's a bigger problem. They've been reliant on Russia, and they haven't tried to get the resource on their own either. So now they have to start trying and do, as we know, I don't want to pick on anybody from England. Oh, shoot, you're an Irish part. Never mind. But they now have to start to get creative in some of the things that they must do in order to maintain what the next resource is. I can tell you it's viably nuclear. I'll just kind of stop there because I could keep going on forever. But
Yes, you could go on forever. Yes, so I guess I'll just take over there. I mean, the one note that I wanted to bring up, the testing going on at the Idaho nuclear facility, 50 megawatt pods, correct?
All kinds.
All
There
kinds.
are multiple sites.
Okay,
28 test sites, right?
So my understanding though is even once those ones get approval and hit market, scalability is going to be a huge problem as well.
Think small, medium, large. But,
Right,
Yep.
right. So keeping in mind the dates that Mark said about when we're going to see nuclear, the amount of power that we need to power not just data center sites, it's all industries that are running into these issues with power shortages. So we need to look at what we have now, what's available, and going back a step. This is basics for a lot of people, but when you start to look at the actual problem that we're having in the States, it's not necessarily a generation. So back up even further. You look at the grid. What is the grid? The grid is any sort of generation, then you have your transmission piece, and then you have distribution. The biggest problem that we have in the States is actually the transmission piece, is getting large amounts of power from A to B. And the reason for that is, one, aging infrastructure. I don't remember the exact number, but it's somewhere roughly on the lines of 70% of infrastructure is coming up on 70 years old, which means that assets are going to start to be taken out of service. We're going to have to build new transmission lines. In order to build new transmission, it takes far longer than building a power site or a substation or distribution lines.
At 5 million a month.
And exactly, the cost involved and the timeline. Prior to my last role, I was a landman, and that's exactly what I was doing. And my experience was nothing like the TV show. And I don't know Billy Bob Thornton, but I was a landman, and all I was doing was acquiring land. We were negotiating rights, and my last role was for a 100-mile long transmission line. And by the time that you do consultation, negotiate with all the stakeholders, finalize all the right-of-ways and easements, and then begin construction, this is a very long process to build a transmission line. And that's not very long. That's only 100 miles. We need like thousands and thousands of miles of transmission in the States to solve this problem. So I just wanted to set the field there that that's really the issue that we're facing. So we can generate. We have the assets to generate the power. So now what we're looking at as an industry is, why don't we bring the assets to the site and self-generate what they're calling behind the meter microgrid solutions. Now there's different technologies that we can use to self-generate on site. My background was in multi-fuel gas turbines. There's natural gas reciprocating engines. There's fuel cell technologies. All of which can use natural gas. So in my opinion, and I think most will agree, that what we have in abundance in the States is natural gas. So why are we not bringing this to site? Or even easier, looking at pieces of land that are close to either pipelines or Marcellus areas, or in West Texas where they have an abundance. So it's interesting, it might have even been this event last year that one of the site selection folks was talking about, when they're looking at the boxes to tick to build a data center, you obviously need water, power, connectivity, and one of the big cons 5 years ago was a natural gas pipeline. If there was ever a natural gas pipeline in the area, they're like, ooh, do we really want to build a natural gas pipeline? They're dangerous. Everyone thought pipelines are dangerous. Now one of the biggest things possible is there a natural gas pipeline in the area, and does it have volume that we can pull off of? And now they're like, hey, let's build a data center by the natural gas pipeline, because there's all these assets that they can use. So maybe I'll just briefly touch on my experience with the microgrids, and then we can turn the conversation from there. But what we were doing, for instance, we had varying sizes of gas turbines. 5.7 megs was our smallest, 35 megs was the biggest, and we could pair those together in lateral to bring as much power as needed to a site. So the reason behind that is, if a data center, one, thought they were going to get their interconnect sooner than they were, for instance, in San Antonio, the utility there overpromised and severely underdelivered, and CPS Energy basically sat down a number of end users and said, listen guys, we told you that your interconnect was gonna be in place by this date, but we simply don't have the power to provide. So there's a number of facilities there that are scrambling, and there's 2 that I know of for sure. One's using natural gas pipelines, one is using Bloom fuel cell technologies. So these are applications that are very viable in many markets across the states, even into Canada. There's one down in Mexico. There's one in Ireland, which has since been told they can no longer do that. But anyways, these are things that, you know, almost everyone that I know of are looking at different ways to self-generate on site.
I think there's a question about transmission, right? I read something the other day that said that to rewire America, which is kind of a big number, they said $22 trillion. I don't know where I read this, but it's just $22 trillion, right? So we're not doing it. So the idea I think we're discussing here, power islands and microgrids, I mean, gas we have. If you look at the gas numbers today, we have hundreds of years of gas, even with growth, it looked like to me. That was also in the Wall Street Journal. It's interesting numbers, a lot of zeros. But I suppose the question is, you know, when you're looking at a data center, of course, what do we need? We need power, we need water, we need connectivity, we need access, and obviously we need gas. And some of these gas lines today, how much gas do we have? And I just read an article too that Western Texas this summer is going to have potentially rolling blackouts because they're going to be 6 gigawatts shy during cooling, you know. So, so the discussion about transmission, you know, can we boost up transmission? Can we get a little bit of both? On that transmission, is it some of it green?
Got a question back?
Paul wants
Go
to
ahead.
talk. Paul wants to talk. Let the man speak.
I got 2 questions.
Wow.
I don't know if we're doing that, sorry. I don't know.
I'd like to hear what you have to say. I'd like to hear.
There's no
I'd
rules.
like to hear from the smart
So,
seats.
all right,
That's
so
what.
I got 2 questions. So I have solar on my house, right?
Sucker.
Oh God. Here we go. Boy, oh boy.
So when I got the solar, I had to go through certain litigations because I have one utility provider in the whole state. I have no other options. They had to approve my system because it's behind the line.
Yep.
And they said they needed to approve it and they needed to make sure that it's regulated. So I have 2 meters. They want to see what's coming out of that system. They want to see what's going in from their line and how much I'm feeding back to them to make sure the credit aligns. Make sure I don't have solar anywhere else on my property, battery system or whatever, and I'm producing that energy. Do you think, or have you seen, with on-site generation, restriction or regulation behind that? And do you plan to see or think you're going to see? Right now, the utility companies are going, we don't have power. Well, when they have the power, are they going to go, you got to stop generation or we're going to cut you off?
So, great question. This leads into something. Don't let me forget about the transmission thing. Keep that one dog-eared. This is the next thing I wanted to talk about. So you're jumping the gun, and I like that. It keeps me honest. Having a conversation with the DOE a couple weeks ago, the conversation came up around privatizing power generation. So I remember, man, I was a kid. It had to be like 1997, sorry for the old people who were already graduated college. But yeah, boy, I just offended half the room. So my first job out of college, I worked for an organization called the NECA, National Electrical Contractors Association. Part of what that was looking at what was going on with deregulation of electricity at the time. And that always leads me to the next question of what's coming next, and when we go from a utility position to a privatized position, are we going to then deregulate privatization, right? So you've got people out there that are going to do exactly what you're doing, okay? And those kind of people are Bill Gates, who Microsoft just put money into the 3 Mile Island, locally here, right? So some people will take that news story and say, Bill Gates just bought 3 Mile Island, right? They'll just take the news story because they're idiots. But he put money into it to refurbish it. Fair enough. Whether you know it or not, Bill Gates also has another company called TerraPower, and he is investing in small modular reactor technology. And I had a conversation with somebody way smarter than me who went, Bill Gates will never operate a nuclear facility. And I'm like, what about TerraPower? And what about the tons and tons and tons of money he just put into 3 Mile Island? Don't those two things come together somewhere to privatize electrical power manufacturing? Because he's no idiot. I mean, he's not a dumb guy. He's not running around the world with a chainsaw trying to hack people to death on stage. But here's a guy who's got the ability, the intelligence, the resources, the money. He's got facilities. He's developing this power. Now we're looking at a very realistic potential. And I don't think this is going to happen in a year or 2 or 3, but 5. It would shock me. It would shock me to death if Bill Gates wasn't in the privatized power distribution position in North America and 10 other people just got online behind him, because they're already doing it. Everybody that is in this position right now who understands that with solar, you have to have either a capacitive or a battery position in line because you use it all right now or you store it. It's the same with nuclear. It's the same with wind. You have these powers. You can't just throttle back a nuclear position and just make a little bit of energy. You've got to make a lot of it, and then you have to put it out to the grid. Then, if that's the case, and it's not government regulated, like, and this is the transmission piece that I wanted to get into, the DOD, and I'll talk about this whole thing after you get to talk about this, or Paul gets to ask another question, but the DOD is taking over the interest from the DOE to kind of soften the blow on regulations. It's not less safe, it's not just cut shortcuts. I want to be very careful how I say that, but the DOD is now taking a very good vested interest in what we need to do to make this a reality, and they have very different opinions. We'll talk about this piece of it, but you have something else you want to say.
So follow-up question. Capacity and scale, right, with data centers, it's all right now. AI, how much infrastructure do you need, what are you supporting, load demand, clients, they don't even know what to ask, right? They're all over the place. So, and, okay, you've got things like different types of AI coming out where they're using way less infrastructure, that's questioning the whole model. Then you've got the changes in the actual NVIDIA chips and what's being utilized and the actually increasing efficiency that's changing, which is driving demand and what do we actually need for power? We don't know. We still don't know. Anybody who says they 100% know, they're out of their mind, right? So with that variation in demand, you start doing on-site generation. What's the plan to capitalize on utilization of that demand? If you're able to supply X and you have now a shit relationship with the utility company because you're on-site generating, can you feed it back? Can you distribute it through the local grid? Is there communal support that you're looking at from a sustainability standpoint? I know I threw a lot out there, but
You did throw a lot out there. Fantastic question, though, and it makes a lot of sense. And I mean, the short answer is yes, you can do that. There are companies doing that. But let's just step back a quick sec and just talk about, you know, those AI loads and the spikiness that they project, and that's very difficult for on-site generation, especially with certain technologies that aren't built for that. For example, gas turbines, like my background. So, I mean, a gas turbine is a workhorse. It wants to be at 60% and higher, and it just wants to pump out power all day long, right? But that's not what an AI workload is. It's going like this all day. But thankfully, our company and others have been using gas turbines for years in the electric fracking market. So the company that I was with, we owned about 70% of that market. And if you know much about electric fracking, what they're doing is they're pumping huge amounts of pressure down a well, and that's what's perforating the wells to extract the natural gas from the well. And all they're doing, they call them stages, and one stage after another all day long. This is a 24/7 operation. They're pumping huge amounts of pressure down the well, and so we'd go from 0 megs to 30 megs and back to 0. So we're doing this all day long. So technicians, over the course of, I'm assuming, trial and error, because like I said, the technology wasn't built for that, but it is very possible to use that technology for those type of loads. So we did have one successful AI data center that it was just that all day long, was the up and down loads. But what you're asking is when it's performing it on, it's never going to be 100%, but whatever the max load might be at this data center, what are we doing when the data center doesn't need any of that load? And there are certain companies, Enchanted Rock, their business model is exactly that. When they're not using the power for whatever it might be, they're putting it back on the grid. And that's how that company, I don't want to speak out of place, but I think that their main business model was behind H-E-B grocery stores, and when there was any blackouts in the area,